Now exercise 1.3, the first question, write the following in decimal form and say what kind of decimal expansion each is. The first one 36 by 10. So here two zeros. So 36 by 10 means dividing by 10, 100, etc. means we will shift the decimal point accordingly. Here you can see two zeros. So we will keep two decimal places. Here no decimal places. So from the rightmost, we will shift the decimal point two places to left side. 36 means 36 point. So here we will shift the decimal point two places to left side. You will get 0.36. Here terminates. Okay, it is not repeating. No digit is repeating. So non-terminating. So it is a terminating decimal. So this decimal expansion is terminating. So it stops. Second one, 1 by 11. So 1 by 11, the decimal expansion of 1 by 11 is 0.0909, etc. That means 09 is repeating. So it is a non-terminating repeating decimal. So 1 by 7 is 0.09 bar. So the decimal expansion is non-terminating repeating. No stop and repeating. Next one 4 1 by 8. It is a mixed fraction. We will convert this mixed fraction into improper fraction. How? Whole number part into denominator plus numerator. 4 into 8 plus 1. 32 plus 1 33. That will be the numerator. Denominator will be the same 8. So what is the decimal expansion of 33 by 8? So when you will divide, you will get final remainder 0. That means stops. You will get 4 points. So 33, how many times? 8 in 33, 4 times. Now remainder 1. Next is decimal point. You can write many zeros after 33. After the decimal point, you can write many zeros. So first 10, 1 time 8. So remainder 220 in 20, 2 times 8, 16. Remainder for 4, 40 in 45 times 8. Okay. So remainder 0. That means it terminates. So 4.4 1 by 8 is 4.125. So this decimal expansion is terminating. Fourth one 3 by 13. So the decimal expansion of 3 by 13, we started from 3 and here it ends 3. That means this process is repeating. This process is repeating. That means 0.230769, again 230769, again 230769, and it will repeat. So it is, there is no end. So non-terminating repeating decimal. 3 by 13 is 0.230769 bar. So it is a non-terminating, this decimal expansion is non-terminating repeating. Next one 2 by 11. The decimal expansion of 2 by 11 is 0.181818. So that means 18 is repeating, no stop. That means non-terminating and it is repeating. So the decimal expansion is non-terminating, repeating. Next one 329 divided by 400. So here after dividing we will get the remainder 0. That means it stops. So the quotient is 0.8225. So it's a terminating decimals. Okay. So after dividing we will get the remainder as 0. So it's a terminating decimal. This decimal expansion is terminating. Next one, you know that 1 by 7 is 0.142857 bar. Can you predict what decimal expansion 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? Study the remainders while finding the value of 1 by 7 carefully. That is the hint given. So first I will write given what is 1 by 7. Okay. Now, what is 2 by 7? 2 into 1 by 7. 2 into 0.142857. That means 0.285714. 3 by 7 is 3 into 0.14. 1 by 7. 3 into 1 by 7. 3 into 0.142857. That means 0.4258571. And 4 by 7 is again 4 into 1 by 7. 0.571428. 5 by 7 is 5 into 1 by 7, 0.714285. 6 by 7 is 6 into 1 by 7, 0.8557142. Here you can see here 142,857. Here 142,857. Here also 142,857. Here 142,857. Here also 142,857. That means these digits are repeating. To predict the decimal expansion of 2 by 7, locate when the remainder becomes 2 and respective quotients. Here it is 2. Then write the new quotient beginning from there using the repeating digits 142857. Repeating digits 142857. So I will explain again. Here, this is the long division of 1 by 7. So if you want to find 2 by 7, you have to locate where the remainder will come 2. Here. Okay. So here 2. So 20. How many times 20? 2 times. So start from here. 2857. 2857 and 14. Repeat the write the repeating digits 285714. See 285714 bar. Now 3 by 7. Where is 3 as remainder? Here 3 is the remainder. So we will start from here. What is the corresponding quotient there? 7 fours are 28. So start from 4. 4 428571. See, 3 by 7 is 428571 bar. Now 4 by 7. Where is the remainder 4 here? What is the corresponding quotient? 7 fives are 35. Start from 5. 571428. So 4 by 7 is 0.571428 bar. Now 5 by 7. Where is the remainder 5 here? 50. What is the corresponding quotient? 7 sevens are 49. Then we start from 7. 0.714285. 0.714285. Now 6 by 7. Start. Where is the remainder here? 6. So quotient 7 eights are. So quotient is starting from 8. 857142. So 0.857142 bar. So to predict the decimal expansion of locate when the remainder becomes 2 and so here to predict the decimal expansion of 2 by 7, locate when the remainder becomes 2 and the respective quotients. Here it is 2. So the respective quotient is 2. So we will write the new quotient beginning from there using the repeating decimals 142857. Okay. So now the next question. Express the following in the form P by Q where P and Q are integers and Q not equal to 0. 0.6 bar. So since we do not know what 0.6 bar, let us call it x. So x is equal to 0.6 bar. 6 bar means 0.66666 etc. Here how many digits are repeating? One digit is repeating. Since one digit is repeating, we multiply x by 10 to get 10x is equal to 10 into 0.666, etc. So when we are multiplying the left hand side by x, we have to multiply the right hand side also by x. So 10 into 0.666 is equal to, when we are multiplying by 10, we will shift the decimal point one place to right side. We will get 6.666, etc. So 6.666, etc. we can write as 6 plus 0.666 is 0.666 is x. So 6.666, etc. we can write as 6 plus x, since x is equal to 0.6666, etc. Therefore 10x is, so 10x is 0.666, etc. So therefore 10x is equal to 6 plus x. Now we will subtract x from 10. So we will get 10 minus, so we will solve for x. We will get 10x minus x is equal to 6. What is 10x minus x? That is 9x. So 9x is equal to 6. Now what is x? 6 divided by 9. Here 9 is multiplied to x. So here we will divide 6 by 9. Now 6 and 9 both are divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So 2 by 3 is the p by q form of 0.6 bar. Now 0.47 bar. Since we do not know what 0.47 bar, let us call it x. So x is equal to 0.47 bar. 47 bar means 0.4777, etc. Here how many digits are repeating? One digit is repeating. Since one digit is repeating, we multiply x by 10 to get 10x is equal to 10 into 0.47777, etc. So when we are multiplying the left hand side by x, we have to multiply the right hand side also by x. Here 10x is 10 into 0.04777, etc. Multiplying by 10 means 10. We will shift the decimal point one place to right side. So 4.777, etc. So now 4.777, etc. we can write as 4.3 plus x. What is x? 0.4777, etc. So how we got 4.3? So we will subtract this x. That means 0.4777 from left hand side. 4.77 minus 0.4777. So decimal points are on the same column. Whole number part minus whole number part is equal to 4. 7 minus 4 is 3. Then 777, etc. up to infinity minus 777, etc. up to infinity is very close to 0. So we will consider this as 4.3. So 4.77, etc. is equal to 4.3 plus x. Therefore, this is 10x. 10x is 4.777, etc. So 10x is 4.3 plus x. Now solving for x, we get here x is added, so here we will subtract. 10x minus x is 4.3. What is 10x minus x? 9x. 9x is 4.3. Here one decimal place you can see. So remove the decimal place. How? Here one decimal place. So we can remove the decimal point by dividing by 10. So dividing here one decimal place means 10. So 43 by 10. Now 9x is 43 by 10. What will be x? 43 by 10 divided by 9. That means 43 by 90. So x is equal to 9x is 43 by 10. So x is equal to 43 by 90. So 43 by 90 is the P by Q form of 0.47 bar. 47 bar. Next question 0.001 bar. So here three digits are repeating. So since we do not know what 0.001 bar, let us call it x. So x is equal to 0.001 bar. That means 0.001, 001, etc. How many digits are repeating? Three digits are repeating. Since three digits are repeating, we multiply x by 1000 to get 1000 x is left hand side into 1000 is equal to right hand side into 1000. 1000 into right hand side, that is 1000 into 0.001, 001, etc. So in 1000 you can see three zeros. So we will shift the decimal point three places to right side. So 1.001, 001, etc. So 1000x is 1.001, etc. So 1.001 is equal to 1 plus x. What is x? 0.001, 001, etc. So 1.001 is equal to 1 plus x, since x is 0.001, 001, etc. So therefore, what is 1000x? 1000x is, that is 1.001 is 1000x. So 1000x is 1 plus x. Now we will solve for x. We will get 1000x minus x is equal to 1. What is 1000x minus x? 999x is equal to 1. So what will be x? 1 divided by 999. So 1 divided by 999 is the P by Q form of 0.001 bar. Now look at several examples of rational numbers in the form P by Q. Q not equal to 0, where P and Q are integers with no common factors other than 1 and having terminating decimal representation or expansions. Can you guess what property Q must satisfy? So one by one, step one by one, we will follow. Here the questions, many questions. So one by one, we will understand what is that. Here first one is look at several examples of rational numbers in the form P by Q. So these are the several examples: 1 by 2, 1 by 4, 3 by 8, 31 by 25, 7 by 125, 13 by 20, and 29 by 16 are several examples of rational numbers in the form b by q and q not equal to 0. Now where q is 0. Where p and q are integers with no common factors other than 1. P and q are integers with no common factor other than 1. Here 1 and 2, no common factor. Other 1 and 4, no common factor. 3 and 8, no common factor. 31 and 25 do not have any common factor. 7 and 125 do not have any common factor. 13 and 120 do not have any common factor. 29 and 16 do not have any common factor. But here I will write 20 divided by 25. 20 divided by 25. Here 20 and 25 has common factor 5. 5 fours are 20, 5 fives are 25. But here nowhere there is a common factor for numerator and denominator. P and Q do not have any common factor other than 1. Look at several examples of rational numbers in the form P by Q. q not equal to 0, where p and q are integers with no common factors other than 1. Okay, having terminating decimal representations or expansion, can and having terminating decimals. So here this one has, what is the terminating, what is the decimal expansion of 1 by 2? So here 2 into 5 is 10. So 1 into 5 is 5. So when we are multiplying the denominator by 5, you have to multiply the numerator also by 5. So 1 by 2 into 5 by 5 is 5 by 10. Here the decimal denominator contains 1 0. So 1 decimal place, 0.5 bar. Next one, 1 by 4. We know that 4 into 25 is 100. So numerator also into 25. You will get 25 divided by 100. In 100, 2 zeros. So you will get 0.25. 3 by 8. 8 into 125 is 1000. So numerator also into 125. 375 by 1000. 0.375. Why 1000 has 3 zeros? So 3 decimal place in the answer. 31 by 25. 25 into 4 is 100. So numerator also into 4. 31 into 4 is 124. So 124 by 100 means 2 decimal places. 1.24. 100 has 2 zeros. Now 7 by 125. 125 into 8 is 1000. Denominator into 8 is 1000. So numerator also into 8. So that is 56. So here 3 zeros means 3 decimal places. Here you can see only 2 digits. The third digits we will take 0. So you will get 0.056. So 3 decimal places. Next one, 13 by 20. 20 into 5 is 100. So numerator also into 5. 65 by 100. So 100 2 zeros to 2 decimal places. Next one, 29 by 16. So 16 into 625 is 10,000. So 29 into 625. So 18,125. Here 4 zeros. So you have to keep 4 decimal places. 1.85, 1.8125. So these are having terminating decimal representation. Can you guess what property Q must satisfy? Here Q is 2. Here Q is 4. That is 2 squared. 2 into 2. The third one Q is 8. 8 means 2 into 2 into 2. 2 cubed. Fourth one Q is 25. 25 is equal to 5 squared. 5 into 5. Here Q is 125. So 125 is 5 cubed. 5 into 5 into 5. Here Q is 20. 20 is equal to 2 squared into 5. 2 into 2 into 5. Here 16. So Q is 16. 2 raised to 4. 2 into 2 into 4. 2 into 2 into 2 into, so 4 times 4. 2 into 2 into 2 into 2. So can you guess what property Q must satisfy? Here you can see Q is either 2 or 5 or combination of 2 and 5. Either 2 or 5. So the property that Q must satisfy is that the prime factorization of Q must have only powers of 2 or powers of 4 or both. So here the property Q must satisfy is that the prime factorization of Q must have only powers of 2 or powers of 5 or both. Why it is like this? When the prime factorization of the denominator of a fraction has only only factors of 2 and factors of 5, the prime factorization of the denominator of a fraction has only factors of 2 and factors of 5. We can always express the decimal as terminating decimal. Reason, we can always multiply the denominator with the required factors and make it to the power of 10. which will always result in a terminating decimal. Here we got the powers, the denominator has the powers of 10. Here 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 2, 10 raised to 3, 10 raised to 2, 10 raised to 4. Powers of 10. So if the prime factor, the factors of the factors of the denominator has only powers of 2 and 5 means we can multiply the denominator with the required factors and make it to the powers of 10. So which will always result in a terminating decimals. So can you guess what property Q must satisfy? Q must have Q must satisfy the property that Q must have only powers of 2 or powers of 5 or both. Q must have the factors of powers of 2 or powers of 5 or both. Now, next lesson will be representing real numbers on the number line and operations on real numbers. These two I will teach in the next class. Up to that, you learn today's class well, understand well, and learn well. Okay, children, all the best now. Bye.